Hello Year 11 and welcome to our 5th video here for indices and logs. Today we're looking at equations with logs and indices, solving equations with logs and indices. We'll rely on the log laws that we learnt lesson before, as well as some of the index laws that we've been practicing earlier on this topic. So, first of all we need to learn this change of base formula. Right? This almost fits in with our log laws from the last exercise. In particular, well, I suppose actually this is one of the more important things that we learn with logarithms altogether, because our calculator can evaluate some logs for us, but only with particular bases, right? In particular, what I mean there is a base 10. So logs base 10, that's fine, but we'll deal with lots of logs that aren't base 10. And this formula will allow us, we're not going to prove it right here, we might get a chance to do that in class at some stage, or maybe with a supplementary video, but this formula here allows us to change the base of a log. Essentially, it's using the new base, the log of the number, divided by the log of the base. Okay, so for example, if I had, here's an example. If I have the log base 2 of 10, and I want to evaluate that, my calculator doesn't do log base 2. It does log base 10. Now I know the answer should be somewhere between 3 and 4, because 2 to the power of 3 equals 8. 2 to the power of 4 equals 16. Now I'll continue to apologize here. I'm sorry, my calculator isn't working. My emulator isn't working. So you're going to have to sort of do this blind. So what we do is log, right, that's the log button on your calculator, L-O-G, log 10, right, and put that over, using the fraction, over the log of 2. So it's going to be the log of 10 over the log of 2 is, I think, about 3.321, I think it was, somewhere like that. A little bit more than 3, right, between 3 and 4. We type that into our calculator, the log of 10 over the log of 2. Right, that's change of base, very important. Now, let's have a look at a couple of other examples here of how we can solve equations using logs and indices. So if I had this problem here, the log base 5 of x equals 2.3, understanding what that logarithm notation represents makes it fairly simple to solve this. We know that 5 to the power of 2.3 equals x, and my calculator will do that fairly well for me. 5 to the power of 2.3. 40.516. I could check that answer. I would have to use my change of base formula. So if I did the log of 40.516 divided by the log of 5, I should get 2.3. Now here is a different type of equation that we might solve. And this is more common, I suppose, where I have a variable in the exponent. So if 7 to the power of x equals 100. Right. Now, this becomes, in a practical sense, perhaps useful when we are solving things like compound formula, and we're trying to work out how long it will take for my interest to reach a certain point. Okay. So, if 7 to the power of x equals 100, I'm going to take the log of both sides, right? The log base 7 of both sides. Then I get this, the log base 7 of this equals the log base 7 of this. Now, using that third log law, the x go out the front and I get x log 7 base 7. And I think that's the fourth log law, or maybe the fifth, is that the log of itself is equal to 1. So the left-hand side becomes 1, right? X log 7 base 7. And over here I'm going to apply the change of base formula. So I'm going to do the log of 10 over the log of 7. Now we said the log base 7 of 7 is equal to 1, so the left-hand side will equal x. 100, right? The log of 100 to a base 10 is equal to 2. Okay, 100 is 10 to the power of 2, so I could say that's 2 log 10 base 10, or 2 times 1 is 2. So this right-hand side is 2 over the log base 10 of 7. And I can type that into my calculator. Make sure when you type it in, it looks very much like that. Right? Check your display to make sure that it's calculating that. And we should get an answer of about 2.367. Again, easy to check that answer. 7 to the power of 2.367. Our calculator will neatly do that. Should come out to being very close to 100. So we've solved two different types of equations today using logarithms and indices, as well as using the change of base formula for logarithms. So the log of the number over the log of the base, right, where I have a log equation like this, then I essentially raise, I take the base and raise the base to each side. So a to the log of this equals a to the log of this. And finally here, if I have an equation that looks like this, I take the logs of both sides, right? The log base a of both sides, and x equals log base a of b. Rightio, that's solving equations using logarithms and indices. Practice those, review the rules, take your time, check it out. It will feel a little awkward at first, but fairly quickly you should fall into the rhythm of using these tools to solve these new equations. And you will find that it becomes really quite helpful for certain situations. If it still doesn't make a lot of sense, please write down those questions so you don't forget and ask me during a meeting. Other than that, I'll see you for our next video or in our meeting. Our next video is graphs of exponentials and logs, and that will bring us close to the end of the topic. Okay, thanks very much, Year 11. Hope you enjoyed.